Hello everyone, Year 7, welcome to the Redbridge Science channel. Today we are going to be looking at filtration. The first thing I'd like to point out is that filtration ends in ation, and words that end in ation or shun are processes, they are things that we do. And the learning objective today, how is filtration used to separate some mixtures? Okay? How do we use it to separate some mixtures? Now there's going to be a lot of key words today. I'm going to be using these 8. And as you can see, they are very similar. Okay? And as we go, I'll explain what each of them mean. And the idea by the end is, can we understand the differences between these words here? So the first one I'm going to do is I'm going to talk about a solute. Solute. Okay, this word here. And this is salt, and salt is a solute. It is a solid that will dissolve in a liquid. Okay? So the definition for solute is a solid that will dissolve. And I'm going to put some into this beaker here. And I'm going to now add a solvent. Okay, a solvent. Now the solvent, in this case today, is going to be water. So I'm going to put some water in there. And the definition of a solvent is a liquid that will dissolve the solid. Now I'm going to use my spatula to give this a good stir. So I'm trying to make my solute dissolve in my solvent. And I'll know if I've managed to do it because this will become clear and there won't be any solute on the bottom. Might have to just give that a little bit more of a stir. And what I've made here now is called a solution. Okay, it is a solution. And a solution is when you have got a solid dissolved in a liquid. So it's when the solid has dissolved in the liquid. Okay, so you can see it's gone clear. There's nothing on the bottom. All of the solute has dissolved. Now the reason that my solute has dissolved is because it is soluble. Salt is soluble, and that means that it will dissolve. Okay, I'm going to skip past saturated and come back to that one in a minute. So soluble means it will dissolve. Now, if I was to keep putting more and more and more solute, salt, into here, I would reach a point where my solution would become saturated. Okay, now saturated is like full up. I'm going to try to show you this on this drawing here. Okay, so at the beginning we've got a beaker here with our solvent, our water in it. Okay, these circles here represent molecules of water, H2O. Okay, so these are all molecules of water. But you'll see that there are little tiny gaps or spaces in between the molecules of water. So when you put a solute, like salt, inside, what the salt will do is it will go into these gaps and it will hide in the gaps. So I know that there is salt in there, but I can't see it anymore. It's dissolved, it's hidden from view, but it's definitely there and it's hiding in those gaps. But if I was to keep adding more and more salt, there would come this point where it can't hide anymore. All of the gaps are filled up, which would look a little bit more like this. So the gaps are all full up, and what will happen is these salt particles along the bottom cannot hide anymore, and they'll start to sit on the bottom of the beaker because they've run out of spaces, they've run out of gaps between the waters. So this is what saturated means, okay? Full up, too much salt. Now the next thing I'm going to do is I'm going to add some sand. Now sand is a solid, okay? And I'm going to see whether I can get the sand to also dissolve. And maybe you could be thinking about whether this is going to work. Think about perhaps if you've been to the beach, when you go down to the beach, does the sand dissolve every time the waves come in? It might wash out a little bit, but does it actually dissolve? I wonder what would happen if you went down to Bournemouth Beach one morning and there was no sand because it's all dissolved. So I'm going to stir for a little while, just to give it a chance. Hopefully you can see that the sand is simply sitting on the bottom. It will not dissolve. No matter how hard I try, I will not be able to get the sand to dissolve. And that's because sand is insoluble. Okay? Insoluble. That means it will not dissolve. So insoluble means it will not dissolve. So right now I've got water, which is my solvent, salt, which is my solute, which has dissolved. So I've got a salt water solution here, but I've also got some sand. My sand is insoluble, sitting on the bottom. What I'd like to try to do now is to separate it. Can I separate that? So this is where filtration comes in. And for filtration we need three things. This is a conical flask, this is a filter funnel, and filter paper. Now with filter paper, fold it in half, and you fold it in half again, and you make sure that the sharp pointed bit is at the bottom. And then what a lot of children do is they put it in there and then they do this. And of course that's not going to work. So what you have to do is make sure that you are putting your finger down one of the side gaps like that. So that what you have is you've actually got three bits of paper on one side, only one on the other. And now it creates that sort of shape there. Okay? So I'm now going to pour my mixture, give it one last stir, and I'm going to pour some of the mixture into here. Now it's important you do it quite gently. Never let the liquid come up above the top of the filter paper. Okay. And what's going to happen is that some will come through the filter paper and some things will not. And what's coming through here looks really, really clean. Okay, nice and clear, and that's good. That's a good sign. It should do that. I don't know whether you can see, but what's being left in the filter paper, not quite so clean. Okay, you can definitely see some bits and pieces. There's a little bit of sand in there. Okay. Now we've got two more keywords here. A residue is left behind in the filter paper. So this is going to be my residue. And in this case, it's going to be the sand. Okay, there's going to be bits of sand left behind in the filter paper. It's a residue. And in most experiments, that's the bit we don't want. Although there are some experiments where actually you do want the residue. What comes through the filter paper into the conical flask is called the filtrate. So a filtrate passes through. And this is my filtrate. Okay? Now, it's just about finished. So here is the residue. And these bits were insoluble. I don't know if you can see that, it's a little bit mucky. These bits were insoluble. This was the sand. It would not dissolve in the water, so it gets stuck in the filter paper, the filtrate. Whereas the filtrate is salt water. Now, I'm not going to prove that to you. I certainly wouldn't drink this, okay? Never drink things in science labs, especially from glassware that you don't know what might have been in it before. But that will be salt water. If I tasted it, it would be salty, just like the sea. Okay? So, 8 keywords, very, very similar to each other. And one more thing I'm going to show you, and that's the diagram here. Okay, so I've named the equipment first of all. We've got the conical flask, the filter paper sitting inside the filter funnel, and a beaker. So in here we'd have our mixture, so this could be obviously the water with the salt dissolved in it and also some of the sand. What's left behind in here would be the residue, and what comes through here at the bottom, this would be our filtrate. So hopefully now, in Year 7, you know how filtration can be used to separate some mixtures. In this case, we've managed to separate the sand from the salt water. Okay, thank you.